In this video, we'll go through the rules of naming alcohols. Recall an alcohol is an organic molecule that contains the hydroxyl functional group. The hydroxyl is simply an OH group that is directly bonded to a carbon. And so, in the case of naming alcohols, it is based on the rules of naming alkanes. So we still have to identify our parent chain, identify any substituents, indicate where things are located, and then put everything together. In the case of the alcohol, when we indicate and identify our parent chain, so we still want the longest continuous chain of carbon atoms. However, the parent chain of an alcohol must include that alcoholic carbon. So recall that is the carbon that OH group is directly bonded to. So we have to include that carbon atom in our parent chain. In this first example, we simply have 1, 2, 3, 4 carbon atoms. So we have 4 in a line. So we have a continuous chain of 4 carbon atoms. So we would call that butane. Butane accounts for those 4 carbon atoms along with their hydrogen. However, we also have our functional group, that OH group. In order to indicate the presence of that functional group, we change the name of butane, so we drop that E and replace it with OL. So it becomes butanol. Butanol accounts for those 4 carbon atoms along with their hydrogen and the hydroxyl functional group. So I boxed off my parent chain, I boxed off the functional group. I don't have anything sticking outside of that boxed area. So therefore I have no substituents. So normally we will be finished. However, in the case of this alcohol, we have to treat that functional group as if it were an actual substituent. So we have to indicate where that functional group is located. Even if it's at the very end of the molecule, we need to indicate where that group is located. So again, alkane chain, so those straight chain of carbon atoms, we can number in 2 directions. So we can number from left to right, or we can number from right to left. But you want your substituent to have the lowest number. Your functional group to have the lowest number. Even if we had substituents present, you want your functional group to have the lowest number. So in this case, we want a number from right to left because it places that functional group on carbon number 1. From there, you put it all together. If we had any substituents present, then they would be listed first in alphabetical order. We would also have to indicate where they are located. So we would have the number followed by the name of the substituent, all in alphabetical order. And then at the end, you would have the parent chain, which must also include the location of that functional group. In this case, because we don't have any substituents, the name of this molecule would simply be 1-butanol. That name indicates that we have 4 carbon atoms in a continuous chain with an alcohol functional group that is branching from carbon 1 of the parent chain. So let's look at another one. So if we look at this molecule, so here we now have a ring of 6 carbon atoms. We have this branched area here. We have our alcohol functional group. And so again, we have an alcohol. So we have to still go through those same rules. Identifying our parent chain. When you have a ring, remember we can count the carbon atoms in the ring. We can count the carbon atoms outside the ring, but we cannot combine the two. They're counted separately. So we have this 1 carbon outside of the ring, the 6 carbon atoms in the ring. So of course the 6 carbon atoms in the ring would be our parent chain. So that parent name, cyclohexane, but because we have that OH group, we're going to drop that E and replace it with an OL. So that accounts for those 6 carbon atoms in the ring as well as the OH group. So I can box it off just to make it easier. So we've accounted for all of this. The only thing left to account for is this branch or that bond that is sticking outside of the boxed area. That bond, 1 bond represents 1 substituent. This 1 substituent contains 1 carbon, so therefore it would be a methyl group. Now we have to indicate where everything is located. One thing about the ring, any carbon could be carbon number 1. However, knowing that our functional group wants the lowest number possible, it tells us that because my functional group is on this carbon has to be carbon 1. That's the lowest number that I can get. From there, I can choose whether I'm going to count clockwise or counterclockwise. So So if I go clockwise starting here, then this will be 1, 2, 3, 4, 5. It will place my methyl on carbon 5. But if I had gone counterclockwise, 1, 2, 3. So you may not have to do that step because you can kind of look and see that it's closer to this end. So that's a clue that this is the way I need to number my parent chain in order to give my substituent the lowest number that it could possibly have. And so now we have our parent chain numbered. We have everything identified. We can now put it all together to name the compound. Again, you need your substituents listed first because I only have this one substituent. It's a methyl. So not only do I need to list the identity of the substituent, but I also have to indicate where it's located. We determined that it's on carbon 3. So I would have 3-methyl. Again, you want to separate your letters and your numbers using dashes. From there, I need to indicate my parent chain. Now, one thing about the cyclohexanol, because it's a ring and I know that my hydroxyl group is placed on carbon 1, I don't have to indicate that in the name. Knowing cyclohexanol tells me exactly where carbon 1 is located. So the name of this compound would be 3-methyl cyclohexanol. If you feel as though you just really have to put a number, make sure that if you put a number, that number is number 1. However, the IUPAC name of this compound would actually be 3-methyl cyclohexanol.